Hi students, welcome to physics class. Today we are going to discuss some important numericals. Torque of equal magnitude are applied to hollow cylinder sphere and a solid sphere. Both have same mass and radius. The cylinder is free to rotate about its standard axis of symmetry, and the sphere is free to rotate about an axis passing through its center. Which of the two will acquire greater speed? Greater speed means we have to find angular acceleration. Now see solution. Moment of inertia of hollow cylinder about an axis of symmetry. I1 is equal to mr square. Similarly, moment of inertia of solid sphere about an axis of symmetry I2 is equal to 2 by 5 mr square. Now torque applied tau is equal to I1 alpha 1. Here tau is equal to I2 alpha 2. Therefore I1 alpha 1 is equal to I2 alpha 2. I1 by I2 is equal to alpha 2 by alpha 1. Therefore I1 by I2 is equal to alpha 2 by alpha 1. What is I1? mr square whole by 2 by 5 mr square is equal to alpha 2 by alpha 1. Therefore 5 by 2 is equal to alpha 2 by alpha 1. That is 5 greater than 2. Since therefore the meaning is that is alpha 2 greater than alpha 1. Therefore alpha 2 greater than alpha 1. Alpha 2 greater than alpha 1. That means angular speed of solid sphere will be greater than the angular speed of hollow cylinder. Now we are going to discuss numerical number 2. A solid cylinder of mass 20 kg rotates about its axis with angular speed 100 second to the power of -1. The radius of the cylinder is 0.25 meter. What is the kinetic energy associated with the rotation of the cylinder? What is the magnitude of angular momentum of the cylinder about its axis? This is the question. Now, given mass m is equal 20 kg, R is equal 0.25 meters, omega is equal 100 radian per second. Now moment of inertia of solid cylinder is mr square by 2. Therefore momentum of inertia of solid cylinder is equal to 1 by 2 mr square, that is equal 1 by 2 into 20 into what is r square, 0.25 whole square, that gives 0.625 kg meter square. Therefore rotational kinetic energy is equal to 1/2 I omega square. Therefore, rotational kinetic energy is equal to 1/2 I omega square. That is equal to 1/2 into 0.625 into 100 whole square. That gives 3125 joules. That is rotational kinetic energy. Now angular momentum is equal to L is equal to I omega. Therefore, L is equal to I omega means that 0.625 into 100 gives 62.5 joules. Therefore, the angular momentum L is equal to 62.5 joules. My dear students, now we are going to discuss numerical number 3. A rope of negligible mass is wound around a hollow cylinder of mass 3 kg and radius 40 centimeters. What is the angular acceleration of the rope? Assume that there is no slipping. This is the question. Now, what the examiner given to us? Here, mass is equal to 3 kg and R is equal to 40 centimeters. That is equal to 40 into 10 to the power of minus 2 meters. Since 1 meter is equal to 100 centimeters or 1 centimeter is equal to 10 to the power of minus 2 meters. Therefore, R is equal to 0.4 meters. Therefore, moment of inertia of the hollow cylinder about its axis. I is equal to mr square. That is equal to 3 into 40 into 10 to the power of minus 2 . whole square. Therefore, I is equal to 0.48 kg meter square. Now, force applied F is equal to 30 newtons. Torque tau is equal to radius into force, gives 30 into 0.4. Therefore, torque tau is equal to 12 Newton meter. If alpha is angular acceleration, produced therefore torque tau is equal to I alpha. From this one, alpha is equal to torque by moment of inertia, that gives 12 by 0.48, that gives 25 radian per second square. Therefore, the angular acceleration alpha is equal to 25 radian per second square. If small a is linear acceleration, therefore the linear acceleration is equal to radius into angular acceleration, that is equal to 0.4 into 25, gives 10 meter per second square. Therefore, the linear acceleration is equal to 10 meter per second square. My dear students, in this numerical, we discuss point number 1, momentum of inertia. Point number 2, force. Point number 3, torque. Point number 4, angular acceleration. Point number 5, linear acceleration. These 5 points we discuss in this numerical. I hope you understood these 3 numericals. Thank you very much for watching this video. Thank you.